Hi students, in this video we are going to discuss non-polarity application. I have selected question number 10.39 from the book, and this is the application on the two groups, sophomores and juniors. Data were collected from 17 sophomores and 13 junior students, and they have asked about their GPA. So the mean GPA of 17 sophomores is given as 2.54, whereas their standard deviation is given as 0.52. The mean GPA for junior students is given as 2.68 and standard deviation is given as 0.32. First of all, we need to determine the relationship between two population variances where the relationship is equal, whether they are equal or not, or considered equal or not. And for this purpose, we need to first apply the CI for the ratio of two population variance, which is based upon F distribution. So I've written down the data already, written down the formula already. And for a 90% CI, we need to know two F values because these two data sets have different sets of values, different sample sizes. When we swap the degrees of freedom, we must be coming up with the uh, different two values. Now f.05 16 column 12 row. We'll first look at the F table and try to determine the F value corresponding to this particular specification. So 16th column, because first number will look in the column and second number in the row. 16th column and sorry, I don't know why this is okay. Now F table we go to. Now 16th column is not there over here. You can see that 16 column is not there. So in case of non-availability of any specific degrees of freedom in left table, we go for the nearest possible available value. So instead of 16th column, we go for or rely upon the value of corresponding to 15th column. 15th column, 12th row, and 0.05 is this one. This is the value 2.62. So 2.62 is the F value, and over here I am cancelling this out, changing it to 15, and 2.62 is the value. Now going back again to the F table, and this time we'll locate the value in the 12th column and 16th row, and just have a look whether 12th column and 16th row is available or not. So 12th column, and that's 16th row. 12th column, 16th row, 0.05 is 2.42. That's the value. This is 12th column and 16th row, and 2.42 is the value. So we note down the value 2.42. Now what we do, we'll take the ratio of two variances, that's 0.52 divided by 0.31, that's squared, multiplied by 1 upon 2.62 0.52 divided by 0.31, that's 2.42. And now we can compute the answers. 0.52 divided by 0.31 squared, then divided by 2.62, that's 1.07. And now the right hand side, at 6.8. Now when we take the square roots, we can now come up with the standard deviation or the ratio of standard deviation. So square root of 1.07 is 1.034, and square root of 6.8 is 2.61. You can now see over here at both lower and upper bounds that the ratio of two standard deviations is exceeding 1 on both the bounds with agreement. It does indicate that we can draw this conclusion that sigma 1 is greater than sigma 2, because sigma 1 divided by sigma 2 is greater than 1. Therefore, it can be concluded that sigma 1 is significantly greater than that of sigma 2. So the variances differ or standard deviations differ now. We need to go for pool-T, non-pool-T application this time. And pool-T has a formula x1 bar minus x2 bar plus minus T alpha by 2. We leave in non-pool T the variances to be different because population variances are not given equal. Rather, we have found these two to be unequal. Therefore, we are applying this approach. But over here, we are given x1 bar, x2 bar. We are given s1, n1, s2, n2. We need to know the t value. But for this, there is a formula that incorporates both the factors that are making a curve steeper or flatter. And these two factors are the sample variances, and the number of observations. And these two are connected in the form of ratio. And the formula is s1 square is to n1 plus s2 square is to n2 and whole square. Then in the denominator, s1 square is to n1, the same thing, but in the denominator with individual squares. The same thing, st square upon n1, but with the individual square. Further adjusted for degrees of freedom. This is how we do it. How we determine? This is how we determine the degrees of freedom in case of a non-polarity application. Now, what we do, we'll substitute the values, and I would tell you the answer that you can check on your part using a calculator. Don't forget to raise this to square as well. 0.31 squared divided by 13, then square, and then divide by 13, take away 1. And when you solve it using calculator, you must come up with the answer as nu equals 26.65. That can be rounded off to 27. Now we go to the t table to locate 90% CI corresponding t value from t table. That's the t table. And 27 are the degrees of freedom, and we are following 90% CI this time. So 1.703 is the value corresponding to 27 degrees of freedom and 0.05 probability from t table. So the value of 1.703. So So now T value for 95% CI is 0.05 for 90% CI. T 0.05 27 degrees of freedom is 1.703, and this is just a matter of substitution of values in the formula. That's 2.54 minus 2.68 plus and minus T alpha by 2 value is 1.703 square root 0.52 squared divided by 17 plus 0.31 squared divided by 13. Now I'm going to work out the answer. That's 0.52 divided by 13. Sorry, divided 0.52 squared divided by 17 plus 0.31 squared divided by 13, then square root of the answer, then multiply this by 1.703 would give us 0.2599 that we can round off to 0.26, and it's 2.54. Take away 2.68 gives us minus 0.14 as the answer. So minus 0.14 and minus 0.26 gives us minus 4, minus 0.4 as the lower bound, and minus 0.14 plus 0.26 is 0.12. Now again, at the time of interpretation, we will drop the sign. That's the rule is, and we decide which is the smaller extent of difference between the two population means and what's the larger difference. So we can interpret this answer as, we can be 90% confident that the difference between the mean GPA of sophomores and juniors is exceeding 0.12 but less than 0.4. Furthermore, if the question is asking us whether the sophomores have exceeded in terms of or outperformed juniors, or juniors have outperformed sophomores, we are unable to say any such thing because the lower bound and the upper bound are coming up with opposite signs, completely conflicting. Both are in disagreement with each other because if you look at the sign for the difference between two population means is coming up negative on the lower bound. This can be concluded that mu1 is less than mu2. If we look at the upper bound, the difference is coming up positive, and due to this positive difference, the finding is completely conflicting. Lower bound is saying mu1 is less than mu2, whereas upper bound is saying mu1 is greater than mu2, and we are indifferent in that case. We cannot simply say that outperformed has that whether sophomores have outperformed juniors or juniors have outperformed sophomores. Okay, so that's all from the question for this session and from the question from non-pool team.